I'm going to discuss projectile in the motion tutorial quite a bit because it's a fairly difficult problem. It's all algebra. Usually students like to see some more numbers instead of just letters. And we just need a recap on projectile motion before we start, just to remember why it's difficult. It's difficult because we have motion in the vertical and horizontal direction. And in the vertical direction, there's an acceleration. It's caused by gravity. It's the acceleration due to gravity, often just written as g. G is equal to 9.8 meters per second squared downwards, which is, it's usually, you'd have to keep track of this of direction, usually with a coordinate system. And horizontally, on the object, there's no acceleration at all. Our recent discussion of forces, we know there's no acceleration horizontally because there's no forces on the object by definition when you're in projectile motion. You're free in the air, and forces are pushes and pulls, and so there's no contact. So the only force that could be on this is the force of gravity, which is downwards, not left or right. So we have constant motion horizontally, and we have motion that's being accelerated. We have constant velocity horizontally, and we have acceleration, constant acceleration vertically. All right, so if we're asked how much time does it take to reach the top, h, we know we're going to have to deal with in the vertical axis. That's a question that's a question about up and down. So we know we're going to have to deal with acceleration. It even gives you a hint. It says find the time as a function of the initial velocity, theta, which is the angle, and g. I've written down the 4 kinematic equations that describe motion, that typically describe motion. And the bottom 3 are have accelerations in them. The top one is for constant velocity, no acceleration. This is the one we could use in the horizontal direction. And these other 3 we can use in the vertical direction because they have accelerations in them, and gravity is an acceleration. It's asking for time, so we're going to look at these 2 and not this one, which doesn't contain time. And this one simply asks us to know about velocities, acceleration, and time. So that one looks pretty simple. Let's consider it first. Velocity final is your initial velocity plus your acceleration through time. We need to know what our initial velocity is, but we have to recognize we're only talking in the vertical direction. Any kind of horizontal velocity will not contribute to how high you rise, which is h. Horizontal velocity will only contribute to how far you end up when you land, this range. And our velocity is a vector at some angle. So this vector is in some way moving to the right and in some way moving upwards. By laying down a set of axes here, this x and y, this gives us a perspective of vertical and horizontal. And this vector can be, if we carefully draw a line, a direct vertical line, parallel to our y-axis, and we draw a flat horizontal line parallel to our x-axis, we can what's called resolve or transform our vector into a hypotenuse of a triangle. And triangles we've learned from geometry to work with. We can establish a sense of proportion between the sides of our triangle, which I'm going to put little arrows on, but it is just a triangle from geometry. But what it represents are three sides of a right triangle, and we can use our trigonometric relations to establish a sense of proportion of the magnitudes of this triangle. So the initial velocity, and some people don't like to see those arrows, so you could redraw the triangle to the side with the same sized sides, and just think of it as a simple triangle where this side is proportional to v0. That's the length of this vector. This side here is proportional to this velocity is on its way upward and rightward. It moves to the right and up. And this side would be proportional to Vy. And if the angle is here, we also could recognize that this is the adjacent side, this is the opposite side, and this is the hypotenuse side, and create an equivalence. So if my kinematic equation is asking for the initial vertical velocity, I need to appreciate that this is in the y direction. Let's remind ourselves, I'm just going to put a bracket around there and say, this is in the vertical direction. So the initial velocity in the vertical direction is not going to have anything to do with this horizontal velocity. So the component of the initial velocity that's just in the vertical direction is this Vy. So initial velocity is Vy. And we're going to use geometry to find out what Vy is. The acceleration is gravity downward, and in our coordinate system, where we have upward being positive and downward negative, our acceleration is negative g. Our delta t is an unknown. That's what we're looking for. And our final velocity, the final velocity of all objects in projectile motion in the vertical direction, because if you go up and come down at the very top, your velocity is for a moment 0. So you're going to have to recognize that and put that in. That's an input from physics thinking. So we can see that our delta t, the change in time, which I think they're just going to call, if you imagine delta t as, I'm going to drop this overall y notation just to make the equation look simpler, but at least there's a reminder here that it's just in the vertical direction. Delta t, remember delta t is t final minus t initial, and if we consider our initial t to be 0 and our t final to be t at time h, then our delta t is just th. I'm going to move it to the right-hand side of the equation because it has a negative sign in front of it. Let's move it over here. There's g th is equal to the initial velocity in the y direction. Divide by g. So what is Vy? Let's look. It's proportional to the opposite side of this triangle. And to relate the opposite, the hypotenuse, and the theta, I can write, and this is a little aside here, I can write sine theta is equal to opposite over hypotenuse. So sine of theta is also equal to Vy, the length of the magnitude of Vy over the magnitude of V naught. Vy over V naught. These opposite is Vy, hypotenuse is V naught. Therefore, Vy, if I multiply both sides by V naught, is V naught sine theta is equal to Vy. If I put those two terms in there, I have an expression for TH in terms of theta, G, and V naught.